Hello, in this tutorial we are going to find out cut length of 4-leg stirrup. Okay, but before that let's see what is 4-leg stirrup. It is made of 4-legged. The cross-sectional area of 4-leg stirrup is twice of cross-sectional area of 2-leg stirrup, and hence it can resist greater stress and the shear force. So here let me just give you the example for the 4-leg stirrup and 6-leg stirrup. It is nothing but 2 stirrups. Okay, if it is 4-leg then it is 2 stirrups, and if it is 6-legged it means that we will have what, 3 stirrups at one location. Don't be confused, it is very easy. Okay, if in the drawing it is mentioned we have 4-legged, then it's mean that we will have what, the 2 stirrups at one location. And if it is 6-legged it's mean that 3 stirrups at one location. Now here in this case we have 4-legged, okay, and this stirrup is called as 4-leg stirrup. The cross-sectional area you can see 18 by 12 inch. This is the column external dimensions. So here we have one master stirrup, means external stirrup. This one is external stirrup. Okay, it is starting right from this position. Okay, it is going in this direction. Okay, and then it will end up till this position. Okay, we have 2 bends over here, and we have one another stirrup, that is internal stirrup. Okay, internal stirrup you can see over here, this one. It is going to start right from this position, here in this direction, here in this direction, it is going in this direction, and we have 2 bends over here. Okay, so because of these 2 stirrups at one location, okay, we will have what, 4 legs, 1 leg, 2 leg, 3 leg, 4 legs. That is why it is called as 4-legged. Okay, so this is nothing but 2 stirrups. Okay, sometime designer suggests as we need to just place 1 stirrup as up till this position, okay, and 1 stirrup as right from this position up till this position. Okay, but in column case we need to use the master stirrup as external, and then we need to use internal stirrup. Okay, now next to it we have 6-legged as well over here, and in some of the cases we will have 8-legged as well. Okay, so all you need to do is, if it is 8-legged then it's mean that we have 4 stirrups. If it is 6-legged it's mean that we have 3 stirrups. Here in this case you can see we have 1 master stirrup that is external. Okay, let me just mark this one, it is external. This is going to join this bar, this bar, this bar, this bar. Okay, this is going to support these 4 bars, this one, this one, this one, this one, directly with these edges. Okay, and we have one another stirrup, that is this stirrup. It is going to start right from this position up till this position. It will be on the top of this stirrup, maybe, okay, on this stirrup, and there will not be any spacing, remember this one. Okay, so right from this position up to this position, the second one. And third one, again on the top of this we will have this one. Okay, it is going to start right from this position, it is going in this direction, in this direction. Okay, so we have 3 stirrups over here. In some cases we have 8 stirrup or 8-leg stirrup as well. Okay, this is 6-leg, 1 2 3 4 5 6. Okay, so hope you really understand the concept, what is 4-leg, what is 6-leg, okay, what is 8-leg. It is nothing but number of stirrups. Okay, 4 mean 2, 4-leg mean 2 stirrups, 6-leg mean 3 stirrups, 8-leg mean 4 stirrups. Okay, now next to it, if you are going to find out the cut length of, let's suppose, 4-leg stirrup, okay, you can easily find out the cut length of 6-leg and the 8-leg as well, because the process is same. Let me just give you one another example. This is practical example over here. Okay, for 4-leg stirrup. Okay, now here in this picture you can see 4-leg stirrup. The first one, the master one, it is going to start right from this position up to this position, then it is going in this direction, you can see. Okay, then it is going in this direction, then again here. Okay, and we have bend over here in this direction and in this direction as well. Okay, so this is basically the master stirrup. And we have another one, okay, that is going in this direction. Okay, then it will go toward this direction, again going in this direction, then in this direction, okay, then here. Okay, so this is what 1 leg, 2 leg, 3 leg, 4 leg. This is nothing but we have 2 stirrups, this one and this one. Okay, so on the top of this master one, okay, we have no any spacing over here. We have another one, okay, this one, the center one, the internal one. Okay, so hope you really understand what is 4 leg stirrup. Likewise, if you have a reinforcement, like we have 1, 2, 3, 4 reinforcement over here, okay, and we have used here what, and the 4 legs, okay, at one end and the another end as well. Okay, so in the same cases, if you have 1, 2, 3, 4, 5, 6 reinforcement at one end and 6 at another end, you can use here what, 6 legged as well. Okay, like the first one, the master one, then another with the next reinforcement, another with the next reinforcement. Okay, so this is the example of 4 legged. Now in 4 legged, the first one is easy, okay, as we find out it earlier, the rectangular stirrup. Okay, but the important thing is to find out cut length of this stirrup. If you can find out cut length of this stirrup, you can find out cut length of any of the stirrup, like internal stirrup, this one, this one, this one. Okay, so let's take an example over here. So let's suppose we have one column as 18 inch by 12 inch and we have used here 2 stirrups, mean 4 legged. Okay, you can see we have one external stirrup and we have one internal stirrup. So external is easy, A into 2 into B into 2, okay, as we did before. This is easy. We need to find out cut length of this stirrup. Okay, given data is over here. A is equal to 18 inch, this is A. Okay, B is equal to 12 inch, this is B. Now dia of dowel bar, it is very important to mention the dia of dowel or the main bars as well over here, because it will be usable over here. Okay, so we are using here number 6 bar, okay, 6 by 8 inch. Dia of stirrup that we are using for the both is number 3, and if it is different then it will be mentioned on the drawing. Concrete cover is 1.5 inch concrete cover, right from this position up till external of the stirrup. Okay, 1.5 inch, and bend we are using over here is 14 into dia of bar. So the main and the important thing is we need to find out the external distance between 2 bars. Okay, it could be any bar, the external distance between right from this position up till here, or external distance right from this position up till here. It is very important to find out this one. When you will find out this distance, you can find out this length of the stirrup, and the breadth is easy, as we did over here, we can find out over here as well. But this is important to find out this external distance plus dia of stirrup plus dia of stirrup will give us the total breadth of the stirrup, okay, at this end. So how we can find out this one? For this, it is very important first to find out center to center distance between external bars. Center to center distance between what? These external bars. External 2 bars, center to center distance is very important to find before finding this one. So how we can find out this one? It is mentioned over here. Formula to find out center to center distance. It is A. You can see over here it is total length of our column. Okay, A minus 2 into concrete cover. This is A, right from this position up till here, this is A. We need to deduct concrete cover from both ends, okay, in order to reach up till this level. Okay, then we need to deduct what? 2 into dia of external stirrup. So we have to deduct dia of external stirrup from both ends as well. Okay, then again we need to deduct what? Half dia of first bar and the last bar as well. We need to deduct half dia of this bar and half dia of this bar in order to reach up till this position. Okay, so let's put the value over here. We know A is equal to 18 inch. Okay, outward dimension is 18 inch. Then we need to deduct a concrete cover from both ends, at this end and this end as well. So concrete cover, it is mentioned over here, is 1.5 inch. So 1.5 inch at one end and 1.5 inch as in other end. Now next to it we need to deduct what? Dia of external stirrup. Okay, at one end and dia of external stirrup at another end. You can see over here we have deduct this one as well. Then we need to deduct what? Half dia at this end for the main bar and half dia at this end for the main or the double bar. Okay, so half plus half will make what? The full dia. That will equal to what? Number 6 divided by 8 in order to convert it into inches. So this distance will be equal to 13.5 inch. Okay, center to center distance between these two external main bars will be equal to 13.5 inch. Okay, and this is the process. Let's suppose if it is 6-legged or the 8-legged, the process will be same. Now next to it, center to center distance between each bar. Now it is time to find out center to center distance between each bar. Mean center to center distance between these two bars, center to center distance between these two bars, and center to center. We need to find out this distance. Okay, this individual distance. First we have find out the overall distance. Okay, so how we can find out this one? The total center to center distance, that is this one, okay, divided by spacing, okay, number of spacing I'm talking about, will give us what? Center to center distance. So this is 13.5, the total distance center to center, divided by spacing we have over here is 1, 2 and 3. Number of spacing are 3. Okay, and if it is 6, like maybe it is number of spacing as 5. Okay, so you need to divide on that. So here we have number of spacing as 3, 1, 2 and 3, so we'll divide it on this one. So center to center distance between two bars will be equal to what? It is 4.5 inch. Okay, 4.5 inch, this one. So now what we need to do is we need to find out this external distance. This is what we need to find out. Okay, this is 4.5 inch. Now what we need to do is we need to find out, this is not center to center, external distance between each bar. Okay, so outward distance I'm talking about. So it will be equal to what? Center to center distance, this one, center to center, right from this position up till here, plus half dia at one end, this one, and half dia at another end, this one. It will give us what? Outward dimension over here. So the outward dimension is 5.25 inch, and this is what 5.25. Okay, now for external length of the stirrup we need to add dia of stirrup at both ends. So this is what we need to find out over here. Now what difficulty over here? Nothing. Okay, if it is 6-leg, 8-leg, the process will be same. Now next to it, let's put the values and find out it over here. Okay, data is the same. Okay, let's go for the formula. Cut length of a 4-legged will be equal to A into 2, okay, plus B into 2 plus hook length minus bend deduction. Okay, so I'm going to find out only this stirrup. Okay, as we have find out it already in rectangular stirrup, remember. Okay, so we can add this value as well, but our main aim is to find out the cut length of this internal stirrup. Okay, so where A is equal to, here I have changed the A, outward distance plus 2 into dia of stirrup. Outward distance 5.25, we have find out it already. Okay, right from this position up till this position, plus 2 into dia of stirrup. So we need to take dia of stirrup as well in order to find out out length of the stirrup. Okay, so 2 into dia of stirrup will give us what? The total length right from this position up till here for this stirrup. Okay, so this is A is changed right now. Okay, and B is equal to this B, the total, minus we need to do what? The concrete cover. We need to deduct the concrete cover at one end, concrete cover at another end in order to find out outward dimension over here. Okay, or you can say it as here. This is equal to this one. Remember this one. Okay, and hook length we now 2 into 14 dB, and the bend deductions we have 2D for the 90 degree and 3D for 135 degree. So we have here what? 3 bends for 90 degree and 2 bends for 135 degree. Let's put the data over here in this. Okay, where A is equal to out to out distance, that is 5.25, plus we need to add dia of bar at this end, dia of bar at this end. Okay, so 2, we have 2 dia multiplied by 3/8 in order to convert it into inches. So A will be equal to 6 inch. This side is, for this stirrup we have 6 inch. Okay, this is 6 inch. And then next to it, B is equal to, as we did before, this is equal to 12 inch, the external minus concrete cover. Okay, this is easy. So B is equal to 9 inch. Now let's find out the cut length. That will be equal to A into 2. Okay, 6 into 2 plus B into 2, 9 into 2. We have find out it over here. Plus we need to add the hooks over here. We have 2 bends over here. This bend and this bend over here. So 2 into 14 into 0.375, minus we need to do the bend deductions. Okay, so cut length of this internal stirrup only, okay, is equal to 36 inch, mean 3 feet. Okay, and all you need to do is you need to add this external as well. Okay, the cut length as we did before in rectangular stirrup, add both of these, and this will be the cut length of 4-leg stirrup. Okay, so this is very easy, I think, and hope you really understand the concept behind how we can find out the cut length of these stirrups. This is nothing but 2 stirrup, 3 stirrup, 4 stirrups. Okay, if you can find out this center to center spacing, you can find out cut length of 6 leg, 8 leg, 10 leg. Okay, it could be any legs. Okay, this is basically the process. You have to find out center to center distance. Okay, this is very important, and hope you really understand this session. I'll see you in the next.